coming back to the Bat Lab in McMaster for the next one, and we have Seheult presenting on efficacy of subcutaneous P-chip implantation in the wing and leg of big brown bats.
Hello, hello. Oh, okay, great. Hello, everyone. My name is Seheult. I'm a graduate student in the McMaster Bat Lab, and today I'm going to introduce a new mark recapture technique to you known as the P-chip tag. And I did a little preliminary study testing its efficacy in big brown bats. So first, I want to talk a little bit about marking techniques. There have been many marking techniques used in bat ecology research, and of course, the need for these marking techniques is because some bats lack distinctive features, right? We want to be able to identify the bats that we catch and re-identify them when we catch them again. And there have been many marking techniques used in bat ecology research, including radio transmitters, freeze branding, bead necklaces, toenail painting, punch marking, and if you get a chance to tour our captive colony here at McMaster University, you'll see that we both band and use passive integrative transponder or PIT tags in our bats. And despite noticeable differences between these marking techniques, they all serve the same general purpose, as I mentioned, to distinguish marked animals. However, no one technique is superior to the others. Some come with pitfalls, right? Some have been shown to affect flight mobility, some have been shown to affect foraging behavior, and some have even been shown to cause injury as well as morbidity in bats. So today I'm going to introduce a new mark recapture technique known as the P-chip tag, which is a 500 by 500 micron semiconductor tag that can be implanted subcutaneously in bats. And the way that this tag works is once you apply a laser beam light to the dorsal surface of the tag, activating the photocell as shown here, a radio frequency signal with a 9-digit number can be sent as a radio frequency signal back to a sensor wand. And this 9-digit number can then be read through a software and recorded. So we wanted to see, does this P-chip tag work as a viable marker for use in bats? We wanted to see if its efficacy compares between two implantation locations, being the wings and legs of bats. And we wanted to see if it has long-term potential for use as a marking technique. And to do so, we conducted many recording sessions, and most notably one a year post the final recording session. So as you can see, we implanted these P-chip tags subcutaneously, both in the wings and legs of big brown bats. And despite their very miniature size, they're somewhat visible, as you can see here in the wing and here embedded in the leg, as emphasized by these white arrows. And now, I want to note that the handheld laser wand used to scan P-chip tags constantly emits a laser light, as you can see here scanning a P-chip in the wing. But once these P-chips are sufficiently activated, you can see a stronger emittance of light, suggesting that the P-chip tag has been sufficiently activated, and thus you would get a scanning of the 9-digit serial number. So for this project, we designed a protocol to scan and record these P-chip tags within the bats, which involved both a handler and a recorder. And the handler's responsibility was to manipulate the animal, expose the P-chip tag in either the wing or the leg location, and use the scanning equipment to scan the tag. Whereas the recorder was responsible for recording any parameters and handling the time. So a given trial would start a bat out of a cage, where the recorder would then press start on a timer. The handler was responsible for opening the bat, held wand when they were ready, when they exposed the P-chip tag within the animal. The handler would then orient the bat to try and the scanning equipment to try and expose this tag and scan it. And once they achieved a successful scan, the timer would stop. And as I had mentioned, we had 11 recording sessions, most notably the yearly follow-up on that day 464 after the prior recording session. So first, we recorded handling time, the time taken from grabbing the bat out of the cage to achieving a successful scan. And as you can see here, we have average handling time over the duration of the study for both P-chips embedded in the leg and in the wing. And as you'll see, as for the rest of the figures in this presentation, the yearly follow-up in a panel on the right side here. And as you can see, the average handling time stayed fairly consistent over the duration of the study for both P-chips embedded in the leg and the wing. However, bats were handled for longer when recording P-chips in the leg versus P-chips in the wing, suggesting the wing might be the preferred location for P-chip tag implantation. We also measured scan time, which is the time duration between grabbing the handheld wand and achieving a successful scan. And as you can see, we have average scan time over the duration of the study for both implantation locations. However, scan times didn't differ between the two implantation locations, except the variance associated with scanning P-chips in the leg did tend to increase. And there was actually somewhat of a trend of increasing for both P-chip implantation locations, which was surprising because you would think with practice effects, using the scanning equipment more often, that scan times would decrease. So this was somewhat of an interesting find. We also measured P-chip visibility as the subjective judgment of viewing the P-chip tag using a yes or no scale. So did you see the P-chip tag while you were trying to scan? And as you can see, the proportion of visible P-chips remained fairly high for P-chips embedded in the wing, although it did decrease over the duration of the study. However, the proportion of visible P-chips in the leg was fairly consistent, about 50%, but always remained less than the visibility of P-chips embedded in the wing, which is somewhat interesting. And this may be due to the ease of seeing P-chip tags in the wing, right? We're much more used to opening the wings of animals and seeing very clearly through the translucent and hairless skin, as opposed to in the tibia where it may be hidden by the calcar or the tail of the animal. We also measured handheld wand flashes. So I had mentioned to you that once you sufficiently activated the P-chip tag, a stronger emittance of light would occur and a successful read would be taken. But we noticed while we were recording that these strong emittance of light would occur without a successful read of the 9-digit number. And we termed these as flashes, right? So when the handheld wand would emit a flash of laser light, but no successful read was taken. And as you can see, the average number of flashes decreased for both implantation locations, but there was no difference between the two implantation locations. And this, again, suggests that practice effect, right? As you become more proficient with the scanning technique and you get used to the location of the P-chip tags, it gets easier to scan without these handheld wand errors over time. And lastly, we measured unreadable P-chips, which were defined as P-chips unable to achieve a successful scan within the maximum allotted time of 2 minutes, 45 seconds. And I think it shows pretty clearly that the wing has 0 instances of unreadable P-chips, suggesting it might be the preferred location for P-chip implantation, whereas the proportion of unreadable P-chips in the leg started off at about 30% and increased over the duration of the study. So what did we find? Well, the P-chip tag seems to be a viable marker for use in bats, right? We were able to record these P-chip tags and achieve successful scans. As you can see from the data, the wing is the preferred site for P-chip implantation and scanning as compared to the leg, as borne out by the data. And through those yearly follow-ups, we found that the P-chip tag does have long-term potential for use in mark recapture field studies in bats. I'd like to thank everyone in the photo, as well as Dr. Bennett and Dr. Alex Borisenko, as well as my supervisor, Paul Four, and everyone who has helped with the P-chip project along the way. I'd be happy to take any questions.
Okay, we're right on time, so we already have some questions.
How does it compare cost-wise to, let's say, pit tagging?
Great question. So you want me to repeat the question? Yeah. How does it compare cost-wise to its alternative pit tags? It's comparable to the price of pit tags. However, typically a pit tag, the tag itself, will cost about $5 to $8 USD, whereas P-chip tags cost about $2 USD each. The problem is with the scanner, and the scanner comes from a sole corporation known as P-chip Corp, and it costs about $2,000 to get this scanning wand, whereas typically for pit tags it costs about $1,500 anywhere to $1,800. So it's very comparable to pit tags.
I may ask my follow-up question.
Sure.
Sorry. So how to circumvent that?
Sorry. Yeah, so the question was for a problem to circumvent the $2,000 price for the scanning wand. And that I'm not sure. I mean, as I mentioned, it comes from a sole source, the P-Chip Corp. I'm sorry, I don't have an answer to that. I'm not sure.
Okay, any other questions? Liam?
Neat stuff here. That's really cool. I'm curious about the visibility section.
Sure.
So you had clear, better visibility with the wing than the leg. I wonder, did you ever have any naive evaluator, somebody who didn't know that there was definitely a P-chip here to find? As in, like, if somebody was marking them and I was to catch a bat, and if I look at the wing, would I be able to find a P-chip, not knowing whether or not there was one there to find?
We haven't yet tested that. That would be really interesting to test, I agree. This was all done during, I'm going to pull the COVID card, so we weren't allowed to have a lot of researchers in the lab, but it would definitely be interesting to see if visibility, because you might not, as you can see through this picture, although they are somewhat visible, you're right, they would be hard to find, especially if you weren't looking for it. So it would be interesting, yeah, I agree, to see if a naive person. Yeah.
Okay, we have another question.
How close does the scanner have to be to the chip to read it?
Yes, so the question, how close does the scanner have to be to the chip to read it? So the scanner actually has to be fairly close, about 8 millimeters towards the chip. And as I mentioned with those handheld wand flashes, it could be dependent on the angle of the scanning wand. So you want to get the angle and the proportion and proximity just right to get a successful scan.
And just to follow up, is that different from a pit tag? Is that how close you have to be with a pit tag?
Yeah, so pit tags can range. There are many different models for pit tags. Some allow for a larger proximity compared to others. I think the ranges are anywhere to 140 or 150 millimeters away. So it is very close, and you do have to get very close to the animal compared to pit tags. But people have also, or researchers have also used pit tag arrays that allow for greater proximity too.
There's a new one, right? So it will be double that.
Yes, there is a new one. I'm not sponsored by P-Chip Corp, but there is a new one coming out that offers a greater proximity range. So they are addressing some of these questions.
Okay, well, I guess we have one more minute here, so we'll let Michelle ask a question.
I was just thinking of other comparisons of the pit tag versus the P-chip. Is there like a longevity on that photo cell that's inside it? Does it last a certain amount of time?
So from what I know, and according to the P-Chip Corp, the photocell doesn't really die off is meant to last for a long time, and is meant to withstand things like thawing and recooling and all sorts of things I can't remember, sorry, off the top of my head. But yes, it is meant to last for a long time.
The lifespan of that.
Yeah, so typically these P-Chip tags are used for marking jewelry, and they've also been used in mice and honeybees. Yeah.
Paintings, art.
Yeah.
So we are actually ahead of time by 5 minutes. I'm not going to make Shane answer any more questions, and I think Paul will buy everybody a reader in the room. Maybe not. Okay. But we're gonna delay and take a breather